Thank you very much. I just want to give you a brief demo on how you can prepare a stock solution you can prepare a dilute solution from a stock solution in the laboratory. You know that for sustainable use of lab resources, it is always advisable to prepare dilute solution from standardized stock solution rather than preparing standardized solution over and over. I just want to give you an example of this. Preparation of dilute solution from stock solution. For instance, how would you prepare 100 cm3 1 mole per dl hydrochloric acid solution from 2 mole per dl hydrochloric acid stock solution? The first thing you take here is you need to use the dilution equation. In a dilution equation, we have the concentration of the stock solution and the volume of the stock solution, which is equal to the concentration of the dilute solution and the volume of the dilute solution. We need to make the volume of the stock solution that is required for dilution the subject. And if we do this, we will have the concentration of the dilute solution times the volume of the dilute solution divided by the concentration of the stock solution. Following this example, if we substitute the values, the volume of the stock solution that is required in this example here will be 50 cm3 of the acid that is required for dilution. Practically, in order to achieve this, the first thing we have to do in the laboratory is safety. Acids are very corrosive, and in order to protect yourself from all this, you need to wear your eye protective goggles. Now you need to wear your gloves to avoid burns. Secondly, since acid is more denser than water, we need to measure the acid and the water. We need a 100 ml volumetric flask. In this 100 ml volumetric flask, we need to measure the acid into it. When we measure the acid into it, then we add water. Now, first thing we do is, let me measure 25 ml of water into this. Using the measuring cylinder. This is 100 ml into acid. This acid, this is distilled water. Into the 100 ml volumetric flask. Secondly, as I said, acid is more denser than water. So we need 50 cm3 of the acid, which is the stock solution for dilution. We have a measuring cylinder here. Measure your 50 cm3 of the acid. Exactly on the mark, we have 50 cm3 of the acid, which is the stock solution. Now, we have to add the acid into the water in the volumetric flask. Acid has been added into the water in the volumetric flask. This is not yet 100 ml. What we need to do is we need to use the distilled water to fill the volumetric flask to the mark. It gives us now 100 ml of the dilute solution. We do it gradually. Okay, now it is at the mark. We now have 100 ml of the dilute solution. Why do we have to add the acid on the water? If we add acid on water, the molecules of the acid are more denser than that of water. So what happens is that The molecules will now diffuse into the water molecules, among the water molecules, and the reaction will be okay. Should in case we added by the water on the acid, water is lighter than, is less dense than the acid. What happens is a layer of the water will be up and the acid will be down. And because of this, there's a reaction that can lead to explosion. And that's why it is necessary you add the acid, not water on it. And this is it. A recap. Preparation of dilute solution from starch solution. The first thing is use the dilution equation. From the dilution equation, you make the volume of the starch solution required for dilution the subject. Then you calculate the volume that is required. From that volume that is required, you now measure the starch solution and put it in the volumetric flask. Then fill in distilled water and make up to the point, and you have your exact 100 ml. That is the simple way of making a dilute solution in the laboratory. Thank you very much.